there, doesn't that look nice? I just moved to this house this year. I really like my new neighborhood. All the houses have such festive decorations. I am really getting into the spirit of Christmas this year. I've heard it said that you can't judge a book by its cover, but can you judge a neighbor by their Christmas decorations? Are there hidden messages and holiday wreaths, lights, and reindeer? How do my neighbors feel about me as a result of my wreath? Do they think me friendly and connected to the neighborhood? Maybe I should have gotten the extra large size. Social psychologists have studied this issue. They use experiments and statistics to understand how social cohesiveness is communicated and reinforced in America. Stay tuned to find out how sociability is related to statistics. I definitely should have gotten a bigger wreath. When we think about scientific experimentation, we usually visualize a laboratory, people in white coats and bubbling beakers. But social and behavioral scientists do experiments too. Psychology has a long tradition of experimentation with laboratory rats and of devising interesting situations for observing human behavior. Of course, there are limits here. Unlike a science fiction author, we usually can't change society just to see how it turns out. We can only watch natural human behaviors. So it's important to have a well thought out plan for our observation. A classic statistical method in experimental science looks for differences that could not have occurred by chance in pairs of measurements. For example, a soft drink manufacturer might wonder whether their Diet Cola loses sweetness over time. This hypothesis can be tested with a t-test. To be more precise, it tests the null hypothesis that the mean sweetness score at the date of bottling is identical to the mean sweetness several months later. This is a paired comparison t-test and uses pairs of sweetness ratings before and after aging. Trained cola tasters rate sweetness, and the same tasters are matched with the same batches of cola. In a similar application of the t-test, an algebra instructor might wonder whether the female students in her class did better on the final exam than the male ones. Here she would test the null hypothesis that the mean male score is identical to the mean female score. Now the statistician uses the two-sample t-test because the exam scores cannot be paired. There need not even be equal numbers of girls and boys in the sample. Both the paired comparison and the two-sample tests evaluate the same hypothesis, that there is no difference between the two groups. In this program, we explore an application of the paired comparison t-test to psychology. I'm here with Carol Werner, a professor in the psychology department and director of environmental studies at the University of Utah. I understand that you ran several experiments to explore the link between Christmas decorations and sociability?
Yes, my colleagues and I, and my colleagues are Dr. Erwin Altman and Dr. Barbara Brown, and some of our students, have been studying how people express themselves as they decorate their homes. We believe that people use decorations to express their tastes and preferences as unique individuals and to express their tastes and preferences as members of the larger social group. For example, when someone chooses a wreath for their front door, they pick one that they like. They express their unique personal preference. By deciding to decorate for the society-defined holiday, such as Christmas, and by using a wreath, the most common decoration at Christmas time, the individual is also expressing agreement with, membership in, that social group of neighbors and friends who are also decorating. In fact, in general, we find that we can predict how friendly a neighborhood is just by looking at the percentage of homes that are decorated. That is, we and other researchers find more decorating in neighborhoods where residents describe themselves as friendly with their neighbors. It's as though people are saying, I'm a member of this group, when they put up a holiday decoration. We were developing a theory that, especially in America, people use their Christmas decorations to send messages to their neighbors. The question is, are these messages received? Well, we thought that they were. We were pretty sure they were. So Barbara Brown, Sonia Peterson-Lewis, and I designed an experiment to study whether outsiders would assume that people who decorate are more friendly than people who don't decorate. We gave the outsiders no information about the residents or the neighborhood. We just showed them some photographs of the homes and the yards, and we asked them to guess how friendly the residents were who lived in those homes. And we used statistical analyses to determine whether the decorations made a difference in the outsiders' perceptions of the residents.
And what was your treatment?
Well, the treatment, which is what you do to the raters to see if you can create a difference, was whether the home was decorated or not decorated for Christmas. We used naturally occurring decorations. We just went into neighborhoods and we took photographs of homes just before Christmas. Another nice thing about this project is that we used many decorated and many undecorated homes. And we showed each of our raters 2 decorated homes and then 2 undecorated homes. That way, the results that we find could not be attributed to differences in the homes, but really to the mere fact that one group was decorated and the other was not.
So how did the outsiders indicate their impressions of the residents?
We had interviewed the homeowners so that we would know which of them were friendly and which were not. We asked them several pages of questions. The outsiders, when our outsiders made their judgments, they used many of the same questions to indicate their impressions of which residents were friendly and which were not very friendly. To give you a feel for this, let me tell you 2 of the questions. One of the questions was, would this resident recognize a next-door neighbor by sight? And another question was, would this resident describe a neighbor as an intimate friend? So 2 questions that kind of get at whether they're neighborly. And the raters indicated the degree of friendliness on a 7-point scale. So they had scores from 1, 2, 3, 4, 5, 6, and 7. A score of 1, 2, and 3 would mean that the resident was probably not very friendly. A 1, it would be a really low score. And then scores of 5, 6, and 7 indicated increasing levels of friendliness, so that a 7 would be a really high friendliness score. And then the 4s indicated the outsider wasn't really sure, or maybe thought there was a little friendliness or a little unfriendliness. And when you think about it, this is a really difficult task. Residents are really variable and they decorate their homes in many different ways. In fact, our outside raters were very reluctant to claim to know someone just from looking at the outside of the house. In fact, that's why we use the paired comparison statistical test. It is a much more powerful test. It's much more able to detect a significant difference between groups.
A single experimental measurement is also a random variable. So is a score compiled from several related measurements, like Professor Werner's sociability index. The mean of a sample of differences is random, and so is the difference between 2 means. All have probability distributions. All may be thought of as drawing from underlying populations. The purpose of the paired test is to determine whether the population mean is essentially 0. In order to explain this, let's first review what you have learned about populations and samples. Here you can see the distribution of the same hypothetical variable, whether it's the final exam score or the difference between 2 sociability indices. When drawing 2 samples from the same population, we'd expect the means of these samples to be about the same. Likewise, when drawing 2 samples from different populations, we would expect different means. But it might not happen like this in every single experiment. Sometimes the 2 samples from the same distribution are quite different. Other times the 2 samples from different distributions are quite similar. The likelihood of such surprises is controlled by the variability of the underlying distributions. Of course, in an actual experiment, we don't know for sure whether the sample was drawn from a 0 mean population or not. That's what we hope to find out. But we will never know for sure because of the uncertain nature of the world. A significance test can quantify our confidence or lack of confidence in the experimental conclusion. How we reach a conclusion is a question of basic scientific method. One widely used method involves a choice between competing hypotheses, called the null and the alternative hypothesis. We begin with the null hypothesis. Suppose that a hypothesized behavior does not actually have any impact. That's the null. Researchers often hope to reject the null in favor of the alternative, but not always. In our examples, the sweetness researchers at the cola company would prefer the null because it implies a product with a long shelf life. And the algebra teacher would prefer the null because it suggests equal education for girls and boys. What was your null hypothesis?
Well, we used the standard null hypothesis, which was that there would be no difference between decorated and undecorated homes.
Okay. Did you ever have any doubts about your theory?
Oh, yes. I remember the study was run in the building where I have my office, and I would get on the elevator with people who had just been in the experiment. And they didn't know who I was because another person had run the study. And they would be complaining to each other about how difficult the task had been. And I really wondered how the study would come out.
Suppose the null hypothesis does happen to be true. That's the same thing as saying that our sample was drawn from a zero mean population. When this is true, would we then expect the observed sample to be measured as exactly 0 down to the third decimal place? Of course not. The reality of sampling error leads us to expect a non-zero result. The fact is inherent in sampling from a probability distribution. If the differences in perceived sociability between the decorated and undecorated homes are small, we cannot rule out the possibility that the measured differences are due to a sampling error alone. Researchers report such experiments as statistically insignificant. If the null hypothesis can be rejected in favor of the alternative, or experimental hypothesis, we can say that the observed difference between the means of the two groups is large enough that it cannot be explained as sampling error. Something else must be contributing to the difference. Hopefully, that is the finding of the experiment. Then the scientist decides that the difference between the two groups is statistically significant. For example, the cola sweetness specialist might call a meeting of his coworkers in the research department to report that artificially sweetened cola loses a significant degree of sweetness over time. And the teacher concludes that there is a significant difference between the performance of female and male algebra students. Okay, now let's cut to the bottom line for Carroll's psychology experiment. Were residents of decorated and undecorated homes rated differently? Was the difference statistically significant?
Yes. Yeah, the results of the study supported our theory. We found that the undecorated homes were thought to have residents who were less friendly than the decorated homes.
Does the expression statistical significance have a different meaning than a layperson might think?
Well, we use it to mean, not that this is a monumental effect, which is what a layperson might think, but we use it to mean that there is a reliable effect. If we did the study over again, we would get the same pattern of results, that residents of decorated homes are perceived to be more friendly than residents of undecorated homes. In fact, if you think about it, the sampling distributions that were shown earlier, what we're asking is whether the two ratings of the two groups of people, those in decorated homes and those in undecorated homes, if they come from different populations.
Okay, based on your experiment, what inferences do you make about perceptions of sociability?
It seems to me that this study supports the idea that naive outsiders assume that decorators are more friendly than people who don't decorate. And in fact, let's look at the scores for the two kinds of homes. The undecorated homes were rated at about a 4 on the 7-point scale, and the decorated homes were rated a little above that, at a 4.4 on the 7-point scale.
By formally stating the hypotheses, experimental method can be more precise. The null hypothesis states that the difference between the means is 0. In contrast, the alternative hypothesis says that the difference is non-zero. Notice that these hypotheses are mutually exclusive. They are mutually exclusive since only one or the other can be true. Of course, there will always be the gray area of small effects that are experimentally undetectable, but these are scientifically less interesting. The t-test allows us to focus on scientifically interesting theories. The decision to reject the null hypothesis is a probabilistic one. This is an important thing to keep in mind. It's really no different than the types of decisions we make every day. When we know for sure that it's going to rain today, we'll take an umbrella. But when we are a bit unsure, we sometimes carry an umbrella on a day that turns out to be sunny. We think about our experimental outcome as a drawing from a normal distribution. The measurement will need to be standardized so that it's consistent with the table of critical values in the back of your text. As you know, this is done by the formula, subtract the hypothesized difference from the measured difference and divide by the standard deviation of the difference. This is a general procedure. It applies to a variety of cases, to both the normal and t-distributions. We always try to use the normal test because the tails of its distribution are smaller. But when our sample size is small, and when the population standard deviation is unknown, the t-statistic is more appropriate. More observations usually contain more information and lead to stronger inferences, But more information can be costly, too. Computing a test statistic is easily done with a computer. In the Excel program, there are 4 options corresponding to different experimental situations. All are found under the Tools menu in the Data Analysis option. If you can't find the Data Analysis option, you may need to add it to your menu using the Add-ins command. Scrolling down, you'll find 4 entries at the bottom of the list. They are t-test, paired to sample for means, t-test, to sample assuming equal variances, t-test, to sample assuming unequal variances, and z-test, to sample for means. They all test the same null hypothesis. Professor Werner's experiment fits the first of these cases. It's a paired comparison test. Although it can be done as a t-test, it has enough observations to be nearly identical to a normal or z-test. With a few cases or many, a formal hypothesis test always involves this formula. We interpret the statistic as the chance that the null is in fact true. The areas under the distribution curves help us to visualize and quantify such chances. There is a relatively large area near to the center of the bell curve, implying that results here are pretty likely. There is a relatively small area far from the center. Observing a test in the tails is unlikely when the null is true, but it is still possible. Now obviously we can't do statistics with concepts like perhaps it'll rain or maybe not. In statistical practice, we use a more formal decision rule to choose between the null and the alternative hypotheses. Social and behavioral statisticians have reached a consensus to reject a null hypothesis when there is a 5% or less chance that it is true. The probability associated with our rule is often called alpha. In principle, we could make the rule be 6%, 1%, or even 20%. The 5% rule is widely used because of scientists' need for a standard method. The region out in the distribution's tail is called the rejection region. It is chosen so that the chance of observing a statistic in that region is 5% when the null hypothesis is true. We include 2.5% from the left tail and 2.5% from the right, so that the total is 5%. It's the area highlighted here in red. We pay particular attention to the values at the border of the rejection region, the critical values. On the right side, this is the smallest value that can be obtained if we want to reject the null hypothesis. Conversely, the area closer to 0 than the critical values is called the acceptance region. It's highlighted in blue. The chance of finding a statistic in this region is 95% when the null is true. Our testing procedure includes 4 steps. 1. State the null hypothesis and an alternative hypothesis. 2. Construct a test statistic. 3. Find the rejection region associated with the 5% significance level. And 4. Decide whether the null should be rejected or not. If the null hypothesis is true, we can expect to find a statistic in the main body of the distribution, in the acceptance region. This outcome is common, but there is a 5% chance that it will not occur. When we get a result in the tails, in the rejection region, we guess that the null hypothesis probably isn't true. That is to say, we reject the null hypothesis in favor of the alternative hypothesis. Keep in mind that it is always possible to obtain a result in the rejection region, even when the null hypothesis is true. In fact, we expect this to happen 1 time in 20, or with a probability of 5%. Now that may sound a little disappointing. You may be thinking, how can we call research scientific if there is a chance of rejecting a true hypothesis? But there is more to science than a single experiment. Even a Nobel Prize-winning study will usually be insufficient to shift accepted doctrine on its own. Scholars are conservative. They will require a large number of confirming studies before they accept a new theory. With many replications, the chance of falsely rejecting the truth is much reduced, below the 5% figure. Let's return to the null hypothesis for this study. If the null is true, then decoration does not affect perceived friendliness, and sample differences between the decorated and undecorated could be thought of as a random variable drawn from a population with a 0 mean. The experimental hypothesis, on the other hand, is associated with the alternative hypothesis. As we discussed above, it says that decorated and undecorated houses are perceived differently, maybe more friendly, maybe less. This alternative hypothesis is non-committal. We can use logic to sharpen our testing method and to refine our hypothesis. Notice that Professor Werner's decoration theory only goes in one direction. She predicts that the decorated houses have higher perceived sociability. It does not say that the decorated houses are more friendly. Instead of the alternative that the means do differ, our alternative should be that the decorated homes are seen to have higher sociability. We can write it in the form of this equation. Suppose hypothetically it happens that the decorated are thought to be less sociable. What then? That certainly does not confirm the theory. We should treat that possibility in the same way as the possibility that there is no difference between the two treatments. Both outcomes, no difference, and the decorated rated lower, are evidence in favor of the null hypothesis. We can take this theoretical information into account by defining the rejection region to be only one side of the distribution. We pick the critical value so that 5% of the area is on the right. Compare this to the usual two-sided procedure of putting 2.5% on each side. Now let's take a look at the data that Professor Werner collected. In this table, you can see the mean ratings for the two sociability categories. The first group, the decorated, had the mean rating of 4.37, while the undecorated had a mean of 4.12. At first glance, it seems clear that the decorated show higher ratings, while the undecorated show less. This is consistent with the hypothesis, all right, but on a 7-point scale, the difference does not seem like a very large one. How would you interpret these mean ratings and their differences?
Well, you can see they're really close together. And as you can see on the graphic, on the 7-point scale, the undecorated homes are rated right at the middle of the scale. It's in that neutral range that I mentioned. And the decorated homes are rated in the positive, the friendly end of the scale.
Although the result is consistent with the experimental hypothesis, we cannot reach a scientific conclusion until we examine the sampling error. Only then can we decide whether the difference they found was too large to have occurred by chance. We need a formal test. Let's go back to our testing method. Our test statistic is defined as the ratio of the mean difference to its standard error. Remember that zero difference is the usual null hypothesis, so the null in this formula is 0. The denominator of this formula contains the expression, the standard error of the difference between the means. That makes sense because the random variable that we are studying is the sociability difference. It has a distribution. It has a mean, and of course it has a standard error. The latter is the measure of sampling error that Professor Werner needs to complete the test. Professor Werner's standard error is 0.091. Plugging these numbers into the formula, we get the test statistic we need. It's 2.74. The final step in our method is to compare our statistic with the critical value. Since we have a large sample, we get the critical value from the standard normal table. It's the familiar 1.64 for a one-sided test at alpha equals 0.05. But what does this mean? Well, it means that we can reject the possibility of no difference between the perceptions of the decorators and the non-decorators. It means that the observed difference, though numerically small, is too large to be accounted for by chance. Something else must be going on. These data provide evidence that Americans do read Christmas decorations as a cue of sociability. Notice the wording that is used here. We said, provide good evidence instead of prove. Why is that? Well, first of all, our finding is only true of the people in this study. Maybe this is one of those cases where the null hypothesis is true. But by chance, the observed statistic is large. We can't rule out that possibility. Let's review a little bit. What we are trying to do is determine whether the difference in perceptions is big enough that it could not have occurred by chance. We estimate standard error as a measure of the influence of chance. If the null hypothesis is true and Christmas wreaths have no effect on perceptions, we would expect the mean difference to be near 0. However, when the difference is large or the estimated standard error is small, the test statistic is going to be large, rejecting the null hypothesis. That's what happened in Professor Werner's experiment.
In another part of this experiment, we asked the people to say what influenced their judgments, you know, how they came up with their ratings of the residents. And many of them said that it was the Christmas decorations that led them to make a rating of more sociability.
And what are some implications?
So far we've talked about a pretty static part of the total research program. By static I mean that you just put up decorations and other people interpret what they mean. A more dynamic part of our theory is that people actively use decorations to invite interaction and become a part of the neighborhood. And we have two kinds of evidence to support this conclusion. First of all, when we go out and look at neighborhoods, people who like their neighbors tend to put a lot of decorations around the entryway. They decorate the door, the porch, the steps. So it's like they're welcoming people at the entrance to their home. People who dislike their neighbors either just don't decorate at all, but if they do decorate, they will put their decorations away from the entrance. And it really does look to us as though people make their entryways attractive as a mechanism for inviting people into their home. And the others who don't want visitors really leave their entryway pretty sterile and unattractive. The second piece of evidence comes from the experiment that we've just been discussing. In that particular study, we targeted newcomers, that is, people who were new to the block, people who wanted to get to know their neighbors. And we analyzed them separately. The outsiders gave them very, very high friendliness scores. And what we found as we looked at the photographs of their homes is that they used a lot of different information. Their aesthetic taste, they expressed aesthetic taste with their decoration. They had a little sense of humor oftentimes in what they would decorate. And their general desire to make the neighborhood look good, to fit in.
Sure.
And it really worked. The observers said that they would feel welcome going into that home. And to me, what that suggests is that people can use decorations deliberately to make friends, to become part of a neighborhood. So if you are in a neighborhood and you see people who have a lot of decorations around their entryway, those are the people who probably would like you to come and visit them and say hi and happy holidays. And if you want people to come and visit you, a good way to do that is to put your own decorations around your entryway.
Okay, thank you for sharing these surprising findings with us, Carol. Happy holidays.
Thank you.
In this program, you have seen how scientists, behavioral scientists, social scientists, and those from other disciplines study cause and effect. You have followed the step-by-step details of the scientific method as applied to a theorized connection between perceptions of friendliness and Christmas decorations. Professor Werner showed us how she used significance testing to be as precise as possible in the face of inherent uncertainty. The sociability perceptions did not uniformly support her theory. Some showed no measurable effect, some contradicted her theory. Even then, she was able to choose between a null and an experimental hypothesis using the paired t-test. The test is not absolutely conclusive. There is a chance that it could be wrong. By using a standard method, she can give other researchers measurements of the level of uncertainty that remains, as well as the nature of the conclusions that are justified. Thanks for watching. Oof, this one's a lot heavier, but I think it's beautiful. Best of all, the neighbors are sure to notice it. Maybe it'll get me an invitation to the neighborhood New Year's Eve party.